Hi everyone, I'm Ruta and I'm a researcher at Meta AI. Today I want to present to you all our work EgoTV, Egocentric Task Verification from Natural Language Task Descriptions. This work was led by Rishi Hajra, who was an intern with our Meta AI team last summer. We are broadly interested in making progress towards egocentric vision-powered assistive agents that are capable of reasoning about daily activities of their users. When invoked via natural language commands, for example while baking a cake, such agents could potentially understand the steps involved in the user's task, track progress through various stages of the task, and proactively prevent mistakes or correct the user's mistakes by making relevant suggestions. Thus, such agents would be very useful to their users in their daily life. However, before such agents could correct or proactively prevent their users' mistakes, such agents should be capable of detecting the mistakes and verifying whether the user is doing the right thing. So to that end, we present a new benchmark and an associated synthetic data set called EgoTV for egocentric task verification. Given a natural language task description and an associated egocentric video of a user performing a task, the goal of the benchmark is to determine if the task has been correctly executed in the video or not. Thus, videos and their task descriptions in our dataset are associated with a task verification label, which can be either positive or negative. We are showing two samples from our dataset on this slide. On the left, we have a positive sample where the natural language task description of apple is heated and cleaned in the sink basin can be mapped to the corresponding video frames, and hence this video's label is positive. On the other hand, on the right, we have a negative sample from the dataset where we actually see that some parts of the task which were described in the natural language are not actually done in the video, and therefore this video's label is negative. To succeed at EgoTV, a model must reason about various ways of doing multi-step tasks specified in natural language. These steps could be done in many orders. Thus, the model must decompose the task into relevant actions, state changes, object interactions, as well as any causal or temporal relationships between these entities. Secondly, the model must ground these entities in the egocentric observations. And lastly, the model should ideally support such reasoning for combinations of tasks, ideally unseen tasks. All in all, we need causal temporal reasoning as well as compositional generalization for egocentric task verification. So you might wonder why we needed a new benchmark and, more importantly, a data set for this. We found that existing data sets out there did not cover all these three reasoning aspects that are necessary for egocentric task verification, namely compositional, causal, and temporal reasoning. We have a detailed comparison with existing data sets in our paper, so please check that out. Secondly, and more importantly, because we generate our data set in simulation, we can provide systematic control and precise diagnostics. For instance, we provide 4 very controlled generalization splits focused on different aspects of generalization, such as generalization to unseen compositions of tasks, unseen environments, unseen affordances, and so on. We find that state-of-the-art vision language models actually struggle at egocentric task verification when it comes to compositional generalization and reasoning about tasks which are described abstractly. So, to enable better reasoning and generalization for egocentric task verification, which we also present a new approach called neurosymbolic grounding. Our approach consists of 3 modules: a semantic parser which converts the natural language task description into symbolic graphs, a query encoder that takes an arbitrary segmented video and the symbolic graph and generates a probability of a graph node being grounded in that particular video segment, and lastly a video aligner which aligns the nodes in the symbolic graph with the video segments. We are able to train this model with just task verification labels without any detailed per step annotations. Our experiments show that NSG outperforms baselines, especially at compositional and temporal reasoning, and this performance remains consistent even when task difficulty increases, for instance, for long horizon tasks. And lastly, NSG is able to reason about task-relevant entities and ground them without any explicit supervision. Last but not the least, we also provide a real-world task verification dataset using the cross-task instructional video dataset to assess the real-world performance of our task verification models. In this dataset, we cannot provide precise diagnostics over various aspects of generalization, but we can assess real-world performance. All in all, we present a new benchmark and a synthetic and real-world dataset for egocentric task verification. We show that state-of-the-art vision language models struggle at various reasoning requirements of egocentric task verification, and therefore we also propose a novel neurosymbolic grounding approach for this. And we open source our code and dataset, so please check them out, and we look forward to chatting with you at our poster on Thursday at 2:30. Thank you.